This video will cover page 3 of the Chapter 1 review, number 9, 10, 11, and 12. So in number 9, we're going to have to say whether the angles are supplementary or complementary. Before we do that, I think it would be helpful if we go in this picture and we find some of these missing angle measures. And so I notice in the picture that angle CFE is a right angle. It's 90 degrees. And so I can find the measure of angle DFE by taking 90 degrees and subtracting 27. When I do that, I see that this little angle here, angle DFE, is 63 degrees. I also know that if angle CFE is 90, angle CFA also has to be 90 because these two make a straight line. They make a straight angle, which is 180. And so if angle CFA is 90 degrees and this little angle BFA is 39 degrees, I can find this angle by doing 90 minus 39. And when I do that, I get this angle's 51 degrees. And so I have all these measures of these angles, which will make answering A through E easier. In part A, angle AFB and angle BFE. If I look at the orange angle and angle BFE, together they make a straight line. They're a linear pair. And so we know that means they add up to 180. And so if I would say they are supplementary. Angle AFC is this 90 degree angle. And angle CFE is this other 90 degree angle. And so together, these two 90 degree angles make a straight line. They add up to 180. So again, these two are supplementary. Angle AFD, using a lot of colors here, this red angle, and angle DFE. Again, these two, angle AFD and DFE, make a straight line, which means they add up to 180, so they are supplementary. Angle AFB, I've already highlighted that one in orange. So angle AFB and angle BFC, this one here. These two, I can see make a right angle. They make up this 90 degree angle. And so when they add to 90 degrees, that means they are complementary. Angle CFD is this 27 degree angle. And angle DFE is this 63 degree angle. Together, they make a right angle, which is 90 degrees. So they are complementary. Using the same diagram from number 9 above, find the following angle measures. I kind of already did that, so I used the picture to find angle measures and then specify whether they were supplementary or complementary. And so you might have been able to do these flip-flop like I did. So I kind of already went and did the work to find these measures. The measure of angle DFE I found was 63 degrees. Remember, I found that by doing 90 minus the 27 degrees. Angle BFC I found was 51 degrees, and I did that by taking the 39 degrees and subtracting it from 90. And now here, the measure of angle BFE, I could do this a couple different ways. I have these three measures now, that I could add all together to find the measure of angle BFE. Or I know angle BFE and angle AFB are supplementary. So this orange angle and angle BFE must add up to 180. So I could do 180 minus 39 degrees to get 141 degrees. There's more than one right way, or more than one way to find these measures. Number 11, point M is the segment bisector of line segment ST. Find the length of ST. We know segment bisectors are in the middle. They cut our line segment in half into two congruent pieces. And so what this tells us is that 2x plus 3 has to be equal to 4x minus 7 if M is the midpoint or the segment bisector. So I'm going to set up this equation. 2x plus 3 equals 4x minus 7. And we're going to solve for x. I need to get all my x terms on one side. I'll subtract 2x here. Need to get rid of this 7 by adding 7 to both sides. Then I need to divide both sides by 2, and I get that x is equal to 5. Now I'm not going to stop here. I need to now use my x value to find the length of ST. I need to find the total length of this line segment. Now I know that x is 5. I can substitute it in for x. When I do that, I see that the length of SM is 13. And when I plug in 5 for x over here, I also get 13, which makes sense because these two pieces are congruent. So the total length of ST is 13 plus 13, which is 26. Number 12, two angles are supplementary and form a linear pair. So let's go ahead and let's draw what this linear pair might look like. It might not be drawn to scale, but here are two angles that are a linear pair. They make a straight line. One angle is 20 degrees less than 3 times the measure of the other angle. Find the measure of each angle. So remember, I need to come up with some expressions for my angles here in order to set up an equation. So first, I'm just going to let one of my angles be x degrees. I don't know what it is, but I'm just going to say, okay, it's x degrees. I need to now use my sentence up above to help write an expression in terms of x, this angle here. So it tells me this angle here is 20 less than, remember less than means subtraction, 3 times the measure of the other angle. So this angle, I need to have 3 times the measure of this angle, or 3 times x, and I need 20 less than that. So my other unknown angle, I get 3x minus 20. And remember, that came from it being 20 less than 3 times the measure of my angle x. So I have my picture set up with my expressions, and I'm ready to set up an equation. These two angles are supplementary, which means they add up to 180. So 3x minus 20 degrees, this angle, plus my x degree angle has to add up to equal 180. I'm going to go ahead and solve for x. I have some like terms. 3x plus x is 4x. I'm going to add 20 to both sides. Divide both sides by 4. And I get that x is 50 degrees. So one of my angles, I'll just call this angle 1, it doesn't really matter. One of my angles was x degrees. So one of my angles is 50 degrees. To find the other angle, I need to take 50 and plug it in for x. When I plug it in, I get that angle 2 is 130 degrees. Notice that these two angles add up to 180. That's good because we know that they have to be supplementary.